We tend to think of the world as, a pretty solid, permanent place. But what if I told you that the biggest features on our planet, the very oceans themselves, are born, they live for a while, and then they die? It's an incredible story, and it's all explained by something called the Wilson cycle. Okay, let's just start with a fact that might completely change how you see the world. Oceans are not permanent. Yeah, those massive blue expanses that cover most of our planet are, in the grand scheme of things, surprisingly temporary. And if you're having trouble wrapping your head around that, get this. The Atlantic Ocean, that giant body of water separating continents, is actually younger than the Himalayan mountains. A chain of mountains is older than an entire ocean. Kind of wild, right? Which leads us to a pretty dramatic conclusion. One day, the Atlantic itself, which is actually getting wider as we speak, is going to hit reverse, start shrinking, and eventually, it will disappear completely. So how is that even possible? How can something as enormous as an ocean just vanish? Well, the answer lies in this powerful, repeating geological process called the Wilson cycle. It's the complete life story of an ocean, and we're going to walk through it step by step. Right, let's start at the very beginning, the birth of an ocean. And here's the first twist. It doesn't start with water. Nope, it starts deep beneath a continent with a whole lot of heat. Okay, so imagine a ton of heat from the Earth's mantle gets trapped under a big continent. It causes the land to swell up and stretch. The source material uses a perfect analogy for this. It's like pulling on a piece of warm chewing gum. You know how it gets all thin and weak in the middle right before it snaps? That's exactly what's happening to the continent. This stretching really happens in two main stages. First, as the continent gets thinner, these huge cracks form on the surface. We call them rift valleys. Then, the crust stretches right to its breaking point, magma rises up from below, and the continent finally splits in two. Seawater rushes in to fill that gap, and just like that, a brand new, narrow sea is born. And the cool part is, this isn't just some abstract theory. We can literally see both of these stages happening on Earth today. The East African Rift, that's a continent in the middle of cracking apart right now. And the Red Sea, well, that's what it looks like right after the split. It's a baby ocean, a narrow sea that's going to get much, much bigger one day. Okay, so our ocean is born. It grows and it matures for millions and millions of years. But, like in any good story, every ocean eventually reaches a critical turning point, a point of no return. For a long, long time, the new ocean just widens. This is its stable adulthood. New ocean crust is constantly being created at a volcanic ridge in the center, pushing the continents on either side further and further apart, year after year. The Atlantic Ocean is in this mature phase right now, spreading a few centimeters every single year. It feels permanent, doesn't it? Eternal? But it's not. This turning point is a process called subduction. So as that ocean crust moves away from the ridge where it was born, it cools down and gets more and more dense. Eventually, it gets so cold and heavy that its edge just starts to sink back down into the Earth's mantle, usually ducking underneath another tectonic plate. And this moment, this is crucial. Once subduction starts anywhere in an ocean basin, its fate is sealed. It might take another 100 million years, but from that point on, as the source puts it so bluntly, the ocean is doomed. This process all builds to the final and most dramatic act in the play, the death of an ocean and the absolutely spectacular collision of continents. So now you've got these two competing processes. New crust is still being made at that mid-ocean ridge, but the old crust is being destroyed and eaten at the subduction zone. And if the rate of destruction is faster than the rate of creation, well, the net result is that the ocean begins to shrink. The continents on either side are now on a collision course. This shrinking just continues and continues until, finally, there's no ocean left to get pulled under. All of that dense oceanic crust has been recycled back into the mantle, and the two lighter, buoyant continents slam right into each other. And what happens when two continents collide? Well, they can't sink, so instead, they crumple. The rock is folded and faulted and thrust upwards, creating these massive mountain ranges. The Himalayas are the perfect example. They're basically the tombstone of an ancient ocean that once separated India and Asia. This collision, this is the death of an ocean. But the story doesn't just end there with a pile of mountains. The death of one ocean actually sets the stage for the birth of the next. The entire thing is a cycle, and there's a really powerful way to visualize it. Remember how this whole thing started? With heat building up under a continent. Well, after several oceans close, you end up with a new supercontinent. And this giant landmass acts like a thick blanket over the mantle, trapping an insane amount of heat. And what happens when that heat builds up? The continent begins to stretch, and thin, and crack. The cycle starts all over again. This brings us to a really beautiful way to picture it all. Think of it like this. The Earth inhales, a supercontinent breaks apart, and an ocean opens. Then, the Earth exhales, the ocean closes, and the continents come back together. In a very real sense, the Earth is breathing continents. So why does all this matter? The Wilson cycle is an incredibly powerful idea. It's not just some cool story. It actually explains fundamental features of our planet. It explains why our oceans have different ages, why major mountain ranges exist where they do, and how continents were once all connected. It shows us that plate tectonics isn't just random drift, but a grand repeating cycle. But what's the ultimate cause? What's the engine driving all of this? This is probably the deepest insight of all. The entire epic story of continents breaking apart and colliding, of oceans opening and closing, it's not really about motion. It's all about heat. It's all just a consequence of a hot planet trying to release its internal energy into the cold of space. And that leaves us with this final, profound thought. The ground beneath our feet, the mountains we climb, the very oceans we sail across, none of it is permanent. Geology gives us this incredible perspective, reminding us that on the vast timescale of our planet, even its largest and most solid features are just temporary arrangements in an endless cosmic dance of creation and destruction.